Yes, dear students, in last video I told you about Ohm's law. Now Ohm's law states that potential difference across a current carrying conductor proportional to current provided physical conditions of conductor do not change. And practically when we study the variation, then we graph straight line. So now question is asked, what are ohmic circuits and what are non-ohmic circuits, and to what extent Ohm's law is valid? Is it universally true or has some limitations? So simply ohmic circuits, if VI graph in a circuit is straight line. Right. Straight line as shown in figure. क्या फिगर होगी? I or V curve, straight line. Then circuit is ohmic. Simple bar. But sometimes we feel unable to give the answer. And the circuits in which VI graph is not straight line. As in figure, as shown in figure. Then circuit is non-ohmic. Actually, dear friend, our language of communication should be so easy that we understand what do we say. So I clearly mention here that electric circuits in which Ohm's law is valid means VI graph straight line. It's called ohmic circuit. The circuits in which, although I have not written valid, but Ohm's law is valid if VI graph is straight line. So that circuit is ohmic. But if VI graph is not straight line, then circuit is non-ohmic. So now you may ask, which are those circuits in which graph is not straight line? Although Ohm's law is valid for wide range, but it has got limitation. So limitation, what are the limitations? Number one, VI graph for a metallic conductor, deviates at large currents. I draw the graph there, IV graph. So it should be straight line, but at large current, this is not followed, it deviates from this like this. Actually, slope of this graph is equal to resistance. We have R equal to B upon I, no? So this B upon this I gives slope. So here, even in metals, Ohm's law loses its validity at high current. For large current it is not. Clear? In case of certain circuits, like in PN junction diode, you will learn semiconductors. Number two is that value of current in semiconductor devices depends on sign of potential. In case of PN junction diode, you will learn in semiconductor the VI graph is obtained as shown here. ये below कह रहा हूँ, क्या होगा भाई? VI graph for 1 volt, 2 volt, 3 volt in volt, I this side in milliampere. It may be like this. Okay. And if we change the voltage sign, 2 volt, 4 volt, minus में होगा ये, तो ग्राफ में come like this. यानी कि यहाँ तो 2 वोल्ट पे इनफाइनाइट करंट है, यहाँ वो छोटा है. तो here Ohm's law is not ultimately valid. Nabi, in case for same voltage there may be two value of current. For same voltage, for same value of potential difference, there may be number 3. For different value of V, there may be same current. In case of gallium arsenide, this semiconductor device actually impurity है तो gallium arsenide, arsenic, gallium mixed with arsenic. The VI graph is obtained as shown below. This V, this I, so the curve may become like this. So at this volt and this volt current is same. But this is V1, here current is this is V2, current is this. And for same, actually once there was a question, actually V upon I is R, and basically this is called dynamic resistance, बदलता रहता है. Dynamic means यहाँ R कैसे लगेगा? V2 minus V1 upon I2 minus I1. So here, suppose this is V1, this is V2, so V2 less than V1, so this numerator will be negative, while denominator negative, positive. So this will be negative resistance. This is called negative resistance. So once there was in board, once the two times has been asked, this graph was drawn and they asked mark the region of negative resistance. Mark the region of negative resistance. So this is the region of negative resistance. Ohm's law. So there are many. I find notice many people. They were criticizing the question. So this is limitation of Ohm law. Ohm law is valid for wide range, but still it has got limitation. Is that clear? So I here give one region here that this is a dynamic. So dynamic resistance. Dynamic resistance का मतलब है in some cases like this or change in curve, resistance changes with change of potential difference across conductor. That is called this resistance. Is called dynamic. Dynamic is which keep on changing position of values. In case of metallic conductor, within the range of Ohm's law, resistance is same at all voltage. But in case of semiconductors, resistance keep on varying. We will learn. PN junction are in one case has no resistance, in other case it has infinite resistance. So resistance keep on changing. So that resistance called dynamic resistance. So this all were the limitations of Ohm's law. Though Ohm's law, I told you, is applicable for wide range of material, but there are materials which do not obey Ohm's law, and the circuit in which VI graph straight line, that is ohmic circuit, and in which VI graph not straight line, non-ohmic circuit. So please read it carefully. Thank you.